Hi, 6th graders. This is lesson 9.4, Measures of Variation. A measure of variation is a measure that describes the distribution of a data set. One simple measure of variation is to find the range. The range of a data set is the difference between the greatest value and the least value. So range is really super easy to find. You just have to order your data from least to greatest, subtract the greatest minus the least, and you have your range. The other measure of variation that we're going to talk about today is the interquartile range. So you've probably heard the word range in there. What we're going to find is the range between the quartiles. And I will show you how to break your data set up into quartiles here very soon. Let's quickly do an example to find the range. These are the lengths in feet of several pythons that were captured for a study. I wanted to find the range of their lengths. So I took the data from the table and I ordered it from least to greatest. I could then easily see that my least value was 5 and my greatest value was 18.5 feet. To find the range, I took 18.5 minus 5, and I got 13.5 feet. So the range in these lengths of pythons is 13.5 feet. So range is very easy and straightforward to calculate. The other measure of variation that we're going to use today is the interquartile range. The interquartile range is the range between the first and the third quartile. First, I need to show you how to divide data into quartiles. So quartiles of a data set divide the data into 4 equal parts. The median is going to be your second quartile, and that's going to divide the data into 2 halves. Your lower half, which is also called quartile 1, and your upper half, which is also called quartile 3. And then the interquartile range is just the difference between the third quartile and the first quartile. The interquartile range represents the range of the middle half of the data, and it's another measure of variation. So in this example, the data set is ordered from least to greatest. It starts with 18 and ends with 37. So we have to order our data from least to greatest. Once we did that, we found the median. The median was 29, and that would also be called Q2. Everything below the median is the lower half or the first quartile, and everything above the median is the upper half or the third quartile. Once you have your 2 quartiles, you find the median of them and then find the range. So 32 minus 22 is 10. I know that seems like a lot of information, and so I'm going to do a couple more examples for sure. Okay, so in this example, we have a dot plot, and the dot plot is showing us the top speeds of 12 sports cars. We're going to find and interpret the interquartile range of this data. To do that, the first thing we need to do is order the speeds from slowest to fastest, then we'll find the quartiles. So I've ordered my data from least to greatest, and I need to find the median first. So remember, the median's the middle, and I'm going to just take one off the front, take one off the back, take one off the front, take one off the back to find my median. When I do that, I find that 245 and 250 are in the middle because there's an even number of data points in this set. So I have to find the mean of 245 and 250. If I add them and divide by 2, I get 247.5. So my median is 247.5, which means that everything below 247.5 is my Q1, or my lower half, and everything above 247.5 is my upper half, or my second quartile. The next step is to find the median of each of those. So in Q1, if I take one off the front, take one off the back, take one off the front, take one off the back, I have two medians. I have to find the mean of them. 230 plus 240 divided by 2 would be 235. So my Q1 is 235. I'll do the same thing with my upper half. So I have take one off the front, take one off the back, take one off the front, take one off the back. Halfway between 250 and 260 would be 255. So the median of my second quartile is 255. Median of my first quartile is 235. To find the interquartile range, I'm going to take 255 minus 235, and I get a difference of 20. So my interquartile range is 20. If the interquartile range is 20, this means that the middle half of the speeds vary by no more than 20 miles per hour. All right, we'll do one more example, and then I'll let you get started on your 9.4 assignment. You can use calculator on this, students. And also, I know that there is a lot of steps in this process, so if you need to re-watch the video or re-watch just an example or two, please feel free to do that because there is quite a few steps. So on number 2 here, we're going to find and interpret the interquartile range of the data. And this is the number of pages in an author's novel. The first thing we have to do is order our data from least to greatest. So I'm going to start by doing that. All right, so I have ordered my data from least to greatest. And the first thing I have to do is find the median. So I can divide my data into Q1 and Q2. So if I find my median, I take one off the front, take one off the back, take one off the front, take one off the back. I continue doing that until I've reached the middle. And I find that 382 is my median. So that's my Q2. Everything below my Q2 is in the lower half, and everything above my Q2 is in the upper half. Now I have to find the median of each of those. So in my lower half, I have an even number of data points. So my median is going to be halfway between 356 and 364. I can add them and divide by 2, and I get 360. So that is my Q1. And then on my upper half, I have 396 and 400 in the middle. So halfway between them, or I could add, divide by 2, I get 398. And that is my Q3. To find the interquartile range, I'm going to find the difference between Q3 and Q1. So I'm going to find the difference between 398 and 360, and I get 38. An interquartile range of 38 means that the middle half of the numbers of the pages vary by no more than 38 pages.